Hello everyone, my name is Niyal Hemant. I'm doing my MSc in Cybersecurity at NCI. My research area will be Intrusion Detection System. And I've taken the title as Improved Network Intrusion Detection System with Minimal Packet Drop using OpenStack Load Balancer. The reason for taking this as my research will be that whenever there's an breach or an intrusion detected, the main aim is that there will be an DOS attack or a DDoS attack in the major cases. So whenever there's an attack like this, there will be a lots and lots of packet will be dropped, and there will be lots of communication gap between the servers and the endpoints. So the table of contents will be as follows. There will be a brief introduction about the research topic, followed by the state of art, that is the previous works, then the proposed approach which I have approached for this research, the proposed implementation and how I'm going to evaluate it, and finally the conclusion for the research topic. In the present world, every data has been digitally stored all over the place, such as the user credentials, such as your social security number, your PPSN number, or your credit card details, your address, etc. There's a high risk if any of this data has been leaked in the public. So what is an intrusion detection system? It is a device or a software application that monitors a network for a malicious activity. Any malicious activity is reported either to the system administrator or collected in the SIEM. What is a SIEM? It is a system information and event management, which has all the logs from the intrusion detection systems. The main aim in this is whether the IDS is capable of holding up in the network whenever there is an intrusion or an attack. Usually an attack will be a DOS attack to the server, which will reduce the server capability, and it might even result in terminating the connections between the clients. So in most of the researchers, they say that whenever an IDS has been installed, it is said that there's a better performance in a Linux based operating system than when it is compared to an Windows operating system by 10% variation. So let's move on to the next, and let's talk about the previous works and the proposed approach. The state of art basically speaks about the previous works done in the same field, intrusion detection system. As we can see in the previous years, 2015, there was an upgraded intrusion detection system for a network-based attack for detecting using a data mining process with the help of a technology called as SNOT, which is the open source tool and widely used intrusion detection system. So as we can also see that in the recent few years, they have tried to add multiple ideas to overcome the strengths and remove the weaknesses of each tool by combining them into one network tool. So as we can see, they were able to overcome, which was resulting in 15% rise in the detection rate in SNOT and 10 packets per second for the processing. That's a quite improvement, we could say. Whereas the speed difference of 82,000 packets per second for the processing was a great overcome. We could also see that they were moving most of the ideas to the cloud, as it is said that in cloud computing you can scale your hardware resources at any point of time. So whenever there's a breach or an attack on your servers, you could just scale up your hardware so that your servers don't go down. But also scaling up means increase in the cost, which is very expensive in most of the cases. So let's not speak more about the previous work, and let's move on to the proposed approach. As we all know, there is some many intrusion detection system available in today's environment which are still not up to the date and still has a lot of bugs in it. Here we propose the advanced intrusion detection where in the ideal servers are placed above the servers, which will come in help whenever there is an DDoS or an DOS attack over the organization. So as we can see, like whenever there's a malicious traffic coming through the router, it just few of them gets filtered out, and when it comes an IDS, if it detects from a same source IP, multiple requests are being sent to the organization servers, then it shall terminate it right over there and it shall not be processed. And at the same time, to make sure that the malicious traffic usually are spreaded by multiple IPs and not by the same IP, so that is a DDoS attack, then the ideal servers come in and they help in trafficking and utilizing the load, and all the logs which are being generated are logged into SIEM usually, but here in the IDS only there will be a separate log file created to log everything, which we will be also be talking in the proposed evaluation how the logs are stored. So basically, if there is a multiple request from a source IP, it gets terminated, and at the same time the ideal servers come into use and they help in processing the traffic as well. So we could also see a node performing a DOS attack and also continuous pinging traffic, and we'll see that how many false negative and false positives lots are created and detected. So we'll also make sure that the false negative traffic from the source IP is terminated as soon as it's been detected, and we'll also make sure that the ideal servers come into the picture as soon as an DOS attack has been created and detected by the IDS. It shall also search for what type of attack, and everything will be detailedly logged in the IDS. A separate log file should be created for the system administrator to take appropriate actions when he goes through the logs. Also making sure the main point here, the research topic is the packet loss. While running an analysis of the network, make sure the false positive rate is reduced to minimal. All the loss must be recorded in the SIEM, which are here done in the IDS by getting a separate log file. So whenever there is an DOS attack or any other attack, there should be very minimal as possible packet loss so that the communication is done perfectly. So moving on to the proposed evaluation, how we are going to evaluate the research. In the proposed evaluation, the security in the network is the most important thing in any organization. The main aim here is to make sure the false positive rate is lesser than the actual systems in the present environment. So once the proposed system has been implemented, the testing will be done based on the accuracy and the detection rate. Once the detection rate has been noted down, there will be a log file created like the table in the left hand side, which shows the source IP, date, time and type of attack. Here the type of attacks are the known attacks which were done in the previous years. If there is an unknown type of attack, it will show as unknown, but it will still show the source IP, date and time. Well, we also want to implement showing that the type of attack has been terminated or it is still active with by adding one more column as the status of the particular attack. Usually when there is a DDoS detected, the IDS which we are going to implement should terminate and carry on with the next process. By having a log table, we can evaluate the proposed system, how efficiently it is than the other previously proposed systems. We could concluded by saying that the proposed implementation we could terminate an DOS attack and with minimal packet loss by implementing a load balancer at the detection stage and also having few ideal servers which are pre-configured and kept ideally behind the server, and it shall only be utilized whenever there is an attack detected by the intrusion detection system, which will not only help in reducing the attack but also it will increase the performance of the server as the servers will share and handle the traffic, and there shall not be a traffic load over any particular server, but since the ideal servers are also being configured by the same work process, it shall be processing simultaneously, and by this we can say that there will be a minimal packet loss during an event of an attack. By this we can conclude the research project. Thank you.